this low power backup situation where we only want to keep the clock alive when we ignore it, and we want to reduce the power consumption of the clock as much as we can. So we disconnect everything that we don't use. And at that moment, we turn off the wireless communication, we turn off LEDs, and we don't have to secure element at that moment. So with this also in the power line, we can actually physically switch off the power to the secure element. There's always have to take into account when you do that, because not only the power will be removed from the secure element, but also you need to make sure that your I/O pins are also at 0 voltage or floating. That's what you guys didn't notice here. Because if you remove the power from this chip, you still have an I/O pin. For example, the chip select at high, then this whole chip will actually be powered through this I/O pin.
Yeah, I know this. Because there are, I mentioned it multiple times in that videos, very often people forget what is inside of the chip. One of the components inside of the chip is the ESD connection diode. And if the voltage on pin is higher than the power voltage, then the voltage on the pin will flow to the power of the chip.
Exactly.
Yeah, okay. So now we can have a look on PCB, I think. And before we continue, I want to point out we have also improved version of this board, or a little bit different version of this board, which is the second one, and then we will focus on the second version.
Exactly.
Okay, so it's two-layer PCB, or no?
Exactly, yeah. So we are still designing with manufacturing series production in mind. So well, electronically it's not a very complex thing. We are designing for a commercial product, so it needs to be cost effective. So we need to lower production costs where we can. So two decisions that you can see here in this design. The first one is that it's two-layer PCB, and you need only the top layer and the bottom layer. And secondly, all the components are on the top side. If you look at 3D, all the SMD components are on the top side, so it only needs one production pass through the pick and place machine and flow soldering. And there is only one through-hole component. Ideally, if you look at the production cost, normally you want, for series protection, you want to have as much SMD as you can instead of through-hole. Because SMD is always an automated production process that's very cost effective to pick and place machine. If you do through-hole, at lower quantities, that means that actually someone has to manually prep this part and put it in a PCB. So that's more expensive.
I'd like to again point out this because there are many people who never seen how PCB is made, how the boards are assembled. I highly recommend to watch these kind of videos. I have done some videos, so I will put links somewhere, and everyone can watch it. It's very important to know how these boards are manufactured because then they can help to design better boards. And exactly what you explained, one of the many things for to think about how much assembly is going to cost. And if we can place all the components on one side only, it can make production much cheaper. Because some people they ask me, I can some tutorials, and in one of the tutorials, the deeper tutorial, and I place all the components on the top. And some people ask me, and then we could place the backup capacitors directly on the microcontroller. Yeah, you can, but then it has to go to the assembly line twice. It costs more money. And exactly as you say, for two-hole components, basically they have to physically take this box, move it to different working points. There are people who will have boxes with the components which they need. They have to put the components inside of the board, and it has to go through the, I don't know, for example, wave soldering, or I think you mentioned you also use the selective soldering, or how is it called?
Yeah.
So we'll talk about this a little bit later. So it's like additional process, more money for production.
Yeah, indeed. Like Robert says, look at how it normally works, and also in case of doubt in your design or something specific that you're not exactly certain about how that would be produced or how it would be done efficiently, don't hesitate to talk to manufacturers, because in the end they also want to sell their service. So they're more than happy to discuss with you what an efficient design would look like.
Yeah. Okay. So was there something tricky from this PCB layout?
Not very much actually.
Because I would be really worried about